Hey everybody, had myself muted right there. Roderick is right. It is coffee time. It's cup of two coffee time. We got some questions from Mohammed right here, Kylie right here, Tiffany, Snea, and Roderick saying coffee time. Oh no, my ear's doing that ringing thing again. Don't be ringing ear. No. It's just one of those days again. I think it's every Tuesday, Thursday. That's what happens. Cliff, good to see you here. Good to see everybody here. Let's see right here. Mohammed started us off. I appreciate you working through number 4 on homework 2 for 474. Let's start off with Mohammed's question right here. Remember, throw those questions in. We're going to try to do as many as we can in the order that we can. So let's go over here to 474, number 2. Go over to assignments. We're going to work a kind of version of it. We're not going to work the exact thing. We're going to work similar work, but not quite the exact problem. So here we are. Let's go down. We're getting it loaded up currently. Here is number 4, and we're going to work a similar version to this. Not quite the same problem, but number 4 for 474. Number 2, let's go check it out. So when it comes to this question on the screen right here, we're basically making a data set where we're going through and finding the average weights by rings. Now, you know what's really interesting? In 474, we just did something very similar to this. Who in 474 knows a very quick function that we could use to check our work? Who in 474 knows a very quick function that we just finished class with, 50 points if you know it, something we know that could check our work right here, and we could find out all the answers very quickly for this. Because we want to know by rings what the average weight is. So we could actually get all the answers right here. It's not going to look quite perfect. And I wouldn't... I mean, you can check your work with this. Do we show the check? Do we have a check? We give you a sanity check down there. Aggregate right there, Snea, that's worth the 50 points. Yep, aggregate we just covered. And we can go, we want to load the EX3 Abalone dataset. Make sure you have reg class currently loaded up. And so we can get a quick check on everything. We're going to go down here. And the way to do it, don't print this to the screen. Remember, once again, Brian does more/different. I always do different work. I want you to be thinking about how this applies to what you're doing to kind of like prime the pump and get you interested in stuff. And I just put out a big message in Discord. If anyone knows anything about the Business Analytics Society, oh, is Mubot not awake? Mubot, wake up, man. We got to re-wake up Mubot and give out those points again. If anyone knows anything about the Business Analytics Society, please contact me. We're trying to figure out where they're at, what's going on. I put a big message out in Discord saying like, hey, if you know what's going on with it, let me know. And it's kind of the second or third time I've asked. We're trying to help the club get going. We got people who want to come and talk to the club, business leaders. So we're hoping to get that going. And we just want students to have avenues for, meeting employers and all that good stuff. And so we want to make sure that's all going. I want to know too, right? Well, the good news is, I want to join the club too. Just want, we're going to try to get everything going well again. So we're going to look into this. 100 points right there. So Mubot, are you working? Mubot, what are you doing? There we go. It's weird. I have to do a few things. It's weird. I kind of broke it. I tried to join last year, but nobody responded to my emails. Yeah, last year was when the club started going away because current world situation. So we're going to try to get things going. I have a big meeting tomorrow, which is kind of be related to it. So wish me luck on that big meeting tomorrow at 11:30. Talking to a person who could help out a whole lot. So really, I think it's just one of those things. And here's the hardest thing. A lot of times with student-run groups, it's students who run it, but we can be there to kind of help. But if you know anyone involved with it currently, I mean, I know the former leadership, and I've been reaching out. If you know anyone, just say like, hey, if you could just say to Brian, I mean, even just say, the club kind of went away. Club kind of no longer exists. I'd say, okay, that's fine. We'll just, people want to still be in it, so we'll restart it right here. So if you know anybody, let me know, because I've been reaching out to them. I'd love it if I saw weight not found. What is in the X3 Abalone? Are we doing meat weight or whole weight? Which one are we doing? We're doing which weight is it? Whole weight. So I'm just going to take that right here. This is not how we're doing it. We're just checking our work. And then we're going to go here to fun equals mean. And there we go. Wow. Well, that's kind of the answer. It's not how we're doing it, though. But man, that makes life easy. This is a sanity check for the whole problem. This is a sanity check for the whole problem. Sometimes there's easy ways to do things with coding, and that's the easy way. I have an email someone gave me. I can reach out. Yeah. If you want to like send me that email to William or something like that, let's figure this out, because you'll be doing a huge favor, because we're trying to figure this out as a department right now, and we want students. We're not mad at anybody. We're not mad. We just want to figure out what's going on and help everyone out, because a lot of people are interested in this. A lot of people want to be part of it, so we want to help out and get this going again. And I understand last year was crazy. This year's crazy. A lot going on. So we just basically did a sanity check of the whole problem, but we're not going to do it this way. We're going to do it the hard way. Now, I'm not going to do your problem. You do have a sanity check on the screen, and this is a quicker way of doing it by using the aggregate y tilde x comma data equals comma fun, the function we're running. So you can find any sort of thing you want, like the standard deviation. There's no standard deviations for these last few ones because I'm guessing we don't have enough observations. You need at least 2 observations to get a standard deviation, or some variation in the variable, which would require at least 2 observations. So the NA right here probably means we don't have enough observations. Don't worry about that. We're just looking at different things. So what do we want to do? Well, I'm not doing your exact problem again, so you can't do exactly what I do. But if I went here and I wanted to talk about students in the Survey 10 data frame, let's clear out the brain. And the students in the Survey 10 data frame have different values of, let's say, handedness. Let's not do handedness because we're doing a quantitative one. Students have different values of number of tattoos that they have. Does this make sense that differences took me for to figure out? Turns out. Oh, it's all those little errors, right? Yep. So students have different values of tattoos. How could I figure out the unique values of tattoos? How could I figure out the unique values of tattoos? Like, like maybe no one has 8 tattoos, but someone has 9 tattoos. That's what we mean by unique values of tattoos. Like if I were to tell you all the values of tattoos that people have, well, people have 0 tattoos, obviously. People have 1 tattoo. People have 2 tattoos. Does anyone have 3? Like, does at least one person have 3 tattoos? Exactly. Snare's right there. We're going to go unique. And after we do the unique right here, and if you ever want it to autocomplete, make sure you have a space, and then you want to make sure it's inside of it. You won't get the autocomplete if you're combining words. So you can actually see here the unique is a vector from 0 to 6. I don't like the way it looks right now. We're going to go around this and do sort. And now we've got the sorted unique. You don't have to have, do we have number of piercings? There's piercings. So I want you to look at, oh man, we got all the numbers. That's a bummer. You don't always have to have all the numbers, because number of phone contacts, you notice, you've got someone who has 0 phone contacts, someone who has 1 phone contact. It doesn't have to have all the numbers. This is when you talk to people and you say, how many phone contacts do you have? And they say 33, and at least one person said 33. No one said 32. So you don't want to make a vector, like here's the wrong way of doing this. You look at the biggest number, 1,000. These 2 things right here are not the same. That's a vector from 0 to 1,000. This is a vector of only the unique values of people's phone contacts. So here we have the vector of unique phone contacts, which is not the same as the value of the vector of 0 through 1,000. Does that make sense? Like, you don't just want to code 0 through 1,000, and you'll kind of notice that with your output too, that it's not going to be just 1 ring through 27 rings. You want the unique values. I'm doing a very similar problem. So with this right here, we want to think, okay, if we want to do something like, Brian wants to look at number of tattoos. Brian wants to look at average piercings for each unique level of tattoo. So if we want to look at the average piercing for each level of tattoo, the first thing I want to do is make a what of people with a certain amount of tattoos. So remember, we're writing our for loop by not writing our for loop. The first thing I want to do right here is make a what for the people with a certain amount of tattoos. Because I want to say, okay, let's look at the people with 0 tattoos and find out how many piercings they have on average. Then let's look at the people with 1 tattoo, find out how many piercings they have on average. Let's look at the people with 3 tattoos or 2 tattoos, find out how many piercings they have on average. So I want to make a what of my group of individuals. So when I'm saying, like, let's just look at the people with 0 tattoos only, there's a lot of ways to do that. Might do it differently today. How can we look at just one group? Just one group of individuals. So just like take a smaller portion of it. I got 2 ways in my head to do it. If you can code it 2 ways, that's better than 1 way. Create a subset, Muhammad right there, 50 points. So we want to create a subset right here. We want to go to subset of our survey 10 data. And check this out. This is where it's going to get a little bit interesting. Remember, this will just take all the data right now. But watch this. If we go here to num tattoos, well, we want to go to num, yeah, correct. We want to go to num tattoos equals. Now, this is where, hopefully, and let's take a look. Let's call this sub. Wow, it's a lot of people. Makes sense, though. It makes sense. Brian took all the people who have how many tattoos? And I'll give you a hint if you look at this. Brian took all the people who have how many tattoos right now? Oh, no worries, Snare. No worries. Brian took all the people who have how many tattoos right now? This is a subset of all the people who have how many tattoos? This is a subset of all the people who have how many tattoos? Be very careful. Not one. So that's where to be careful. 50 points right there. Don't worry. Not one, because I'm returning not 0 through 6. Good guesses right there. I'm returning. Look at what I'm returning right here. This is a subset of all the people who have. Jack got it right there. 0 tattoos, because it's the first element of the sorted unique vector of tattoos. So it's the first element of the sorted unique vector. So I could change this right here. Now be careful. This is now a subset of all people who have how many tattoos? You could confirm by looking at it. But this is a subset. Yep. You see it right there. This is a subset of all people who have how many tattoos now? I love it. I love the O's in the chat. 50 points like, oh, that is, I see it. Of 1. And you can confirm by looking at it and going to number of tattoos. It's in here somewhere. Where are you at? We should see a bunch of 1s. There we go. And you can confirm these are all people who have 1 tattoo. Now it's 1 because it's the second element of the unique tattoos vector. So very important right there. We see what's going on, that we're taking only the people who have 1 tattoo because that's the second element of the unique tattoo vector. So when we run this right here, we want to go to our sub, and in the sub we want to get, and this is just our made up question, the number of body piercings they have. There's their body piercings. And we want to go to the mean of the number of body piercings. We can do na.remove just for good, just in case there's NAs. I don't think there are. But that's the mean for this group right here. And then here's where it gets interesting. Mean body pierce. As I spell piercings, sure. And then we're going to store a blank vector right here. And this is where, yeah, let me think. Yeah, it'll be fine. It'll be fine. Double checking my brain. We're going to go right here, store this into 1. Whoa. Oh, I'm screenshotting or something. That was weird. Don't even know what I did. We're going to put this back to 1 right here. And there we go. And then we want to change this to 2. It'd be easier if I just changed this 1 to a what? Because it's a lot of work to change both of these. What do you think I should change? Because I'm changing this each time, and it just goes up each time. And you notice my vector is getting longer for mean body piercings. What do you think I should change that 3 to? These 3s, which be careful, you don't always change them to the same thing. You have to look how you're indexing them. What do you think I could change that to right here? This is the practice you want to do. These are the steps to making it correctly. If you just go through and make everything at once, it's not going to work. We want to change it to an I right here because that's just a placeholder. And then my code would run the exact same way. If I'm outside right here and I go I save into 1, it runs the same way. So if you notice right here, I can go I save into 2 and run the code again. And I might be able to go right here and go this and just go I equals 3, run the code again. Go right here and go I equal 4, run the code again. Go right here and go I equal 5. This is your answer to other questions. If you're wondering about other questions, which ask you, what is the code doing? This is what that code is doing, because now we're going to put this into a what? We actually just solved the problem that I made up, because we do get the vector. We're going to put it into a data frame now, but we just showed what the code is doing by changing what the placeholder is to the next element of the vector and then running the skeleton. Changing what the placeholder is to the next element of the vector, hint, hint, hint for other ones, and then running the skeleton. I like to leave it as is. Technically, I is 6. I think one of your questions wants you to put I6 right there, but I is 6 right now. I is 6. 6 is I. We are 6. So right there, that's what we got going on. And yeah, that's a good hint for like a number 2 or something, I think. Like that's what it's doing. It's just changing what the placeholder is to the next element, running the skeleton. Changing the placeholder, running the skeleton. Big loops right there. So we have the skeleton, hint, hint, hint. But in this question right here, we're supposed to make a data frame. I'm going to do it the quick way. Everything's nice the quick way. We'll do it the right way. So we want to go right here, and we're going to take our unique vector right here, and let's go to our unique vector and say unique pierce. Is this the piercings we're doing? No, unique tattoos. These are the unique levels of tattoos. Would everyone agree with me? These are the unique levels of tattoos. Does that make logical sense? We just stored a vector of unique tattoos. And now I want to store zeros, because the problem says. I want to store how many zeros there are. How could I figure out how many unique values of tattoos there are? How could I figure out, remember, I want to look at this. I want to figure out how many unique tattoos there are. How could I figure out how many unique tattoos there are? I'd be very careful. We're going to put a note. Brian's code is out of order. If I try to knit this, knitting will have problems. My code is out of order. You want to reorder your code. Yep. So I want to go here and go length. And that tells me that there's 7. I had this in my copy paste. It's just this right here. I'm throwing this inside of a length. It might as well just be X. We're just getting the length of that thing you see on the screen. This is 474. Good questions right here. So this is 474, which will tell us where the trues are at. We just want to know how many things are in there. So we're saying, how long is that thing? What is the length of that? And the length of that is 7 right there. And so we have the length of it right here. So now length is just set, like this whole thing right here. This whole complicated thing is just what? Put it in the chat. Like that whole big complicated thing right there is just what right now? Like that's a lot of code. Someone's like, oh my gosh, you want the length of a sorted unique vector of the tattoos people have. So you want to ask people, what are your tattoos? You want to find out what unique values people gave. You want to sort those unique values. Oh no, Alyssa, ask a question. We'll do it here in a little bit. Yeah. Office hours for everyone right here. And this is very similar to 320, what we're doing. Type count. Oh yeah. Everything you see on the screen right there, all that code highlighted is just the same as saying what right now. All that code is just a complicated way to tell what number. It's just a complicated way to say what. Which is like, really, Brian, you're just overcomplicating this. But it's finding this answer for me. All this code right here is a complicated way. We're going to find out how many zeros there are, and there are 7 zeros, because that code evaluates to 7. So when you see what's about to happen right here, and it's going to look complicated, we're just saying rep 0. What? Rep 0. Finish my sentence. Like, I know this is a whole big thing right here, but rep 0. Rep 0 what? This says repeat 0. And when I run it, you'll see what it's doing. Remember what this evaluates to. And so we'd say repeat 0. And then the big thing right there is just saying repeat 0 what? Because that's what it's going to do for us right here. So we're going to repeat 0. Exactly, Snape's right there. The number, the length, the number of the unique values, which is just 7. Repeat 0 7 times. Because that whole big thing right here is just 7. So you're just saying repeat 0 7 times. Does that make sense right there? Repeat 0 7 times. Because everything right here is 7. It's just a really long way of saying find the length of the sorted unique vector, which is going to be repeat 0 7 times. Because that's the length of the sorted unique vector. In better wording without talking coding, it's just saying, we asked people how many tattoos they had. We found out the unique values people gave. Like some people said 0, some people said 1. Those are the unique values they gave. We then sorted it into the order, and then we found out how many different unique values there are. So just try to speak it to your rubby ducky. And so now we're just going to store this as AVG weight. And now we're going to go over here to our data frame and go unique tattoos, comma, AVG weight, make the code look all pretty. And look at that, we got that right there. We're going to store this into DF. I like to call the things DF if we have it. And now we're going to take this right here. And now the code changes a tiny bit. Watch out. Clean up your code afterwards. The first question of 2, yeah, take a look here in a moment. You got it. I think, yeah, definitely, Alyssa. Thank you so much for asking. And now I'm going to store it into the DF right here. So let's try running this with I save into 1. And did this run? Let's look at our data frame now. Ooh, no. Not good. We want to store into average. Oh, we don't want average weight. Oops. We want mean body piercings. Let's go change that. This is mean body piercings. Oh, I'm going to put this here. There we go. Now let's run it. Okay, now let's look at our data frame. Ooh, what do we got going on? Store into, oh, I still have average weight right there. We want mean body piercings. Check what you get. Is that looking correct or no? How's that looking? Make sure your code does what you want. Make sure your code does what you want. We've been doing this in those little bits. Don't write all your code at once. Don't write all your code at once. Because now that I have this working, what's the only thing that needs to happen right here? Do you see it? This is the way to... Oh, did I skip one? No, I didn't skip one. We need to do it for each unique, exactly for each unique value. And then we want to do it for the sorted unique value, so it goes through 0. Actually, we could do it, the way we wrote this, we could actually do it out of order. So this right here is the skeleton. We don't need it to print that. Let's go here. Remember, clean up your code afterwards. Don't like look at what you print. Clean it up afterwards because this is not cleaned. We have right here that the variable is what? We're going to do another question after this, so we got this. Good job, everybody. What is the variable? You should see, by the way, I wrote my code. What is the variable? The variable is the placeholder for what changes. So the variable is the placeholder for what changes. So what is the variable? The variable most definitely in the code I wrote is the what? Brian's variable for the way he wrote everything is what? Oh, I'm on top chat. No wonder. Live chat. I right there. Great job, Snea. Excellent work. It is I. Now, this is what's confusing to people is remember that this right now returns 7. Oh, it returns that. Well, actually, you know what? But you got to be careful right here. Here's the thing. We don't want to store to position 0. We want the first element of this. So you have to be very careful the way you write this. We want the first element of this vector. And the first element of this vector will go into, so we're going through the sorted unique vector, and we're going to I. So actually, you know what? We could grab this right here the way it's written. And everything we've written it, the way we've done it today, might be a little bit different than the way we did it last time. There's the body of the function. And you know what? I think, yeah, this is a little bit different than the way I did it last time, I think. There we go. Re-indenting the code to make it look nice. So it needs to go 1 through the what of this vector, because it's going to do it for each element. It needs to go 1 through the what of this vector, because that's a vector right there. It needs to go 1 through the length of that vector. All this does right here is going to return what? All this code right here is going to print is 1 through what? Be careful. It's a little confusing. All that code right there is going to print is what? Be careful. The answer on the screen is wrong. All that, because you can kind of tell what it's going to start by printing. All this code right here is going to print is blank through blank. And I did it earlier by running my loop, and you can kind of tell the answer to the thing. All this code right here is going to print what? Because it's going to do each element of the unique vector. Be careful. Really close, William, right there. 50 points. 1 through 7. 1 through 7. Yeah, 1 through 7. Yeah, don't worry. This is just like checking me, like, can I read this? It's going to do it for the length. It's 0 through 6, which is the length of 7. So it's going to go 1 through the length. It's going to do it for every element. So right here, we're going to run our code. We can see the answer we have. Let's run it. And then let's look at the data frame, and we've done it. A lot of work for something we could have done using the aggregate function, but it's good practice. And this is very similar to your problem right here. You just have to think about how to write your code. Now, once again, if you just take my code and try to copy it, my for loop was a little different because I noticed the unique values aren't sequential. Yes, exactly. So mine would take, and if there was something out of order right here, when it runs this, it will run it in a different spot. So yeah, that's what you notice is there's missing spots. So make sure you have it working, check your answer, and you can always check your answer to the question by looking at this. Oh, ex3 abalone not found. If you want a check for what you should get, here is a check for yours, a full sanity check. Here is a full sanity check, and you can see we are missing things like 25 in here, which makes it a little bit confusing. If you're looking for a full sanity check of your problem, there is a full sanity check. Yep. And so great work right there. I think we had a few 320 questions. Let's see. Thank you, everybody. Great work. Kylie asked next for 201, can you do the questions about the spinal cord injuries in chapter 4? That's scary right there. Let's go check that out. And then Snea has a question too. Tiffany has a question. Then we have another 320. Let's see if we can get them all here on Morning Office Hours. Let's do the spinal cord injury. Okay, let's hop over to a little 201. Really good 474 question right there. Pretty tough question. Let's go grab that 201 question. Spinal cord injuries. Oh my God. That's a scary question. Probably some box plots right here. I'm trying to think if I remember this one. Like, I'm thinking, like, what is this question again? What is this? Like, I can't think of it. I can think of the horse race question, the ones we just did right there, the baseball team question. Let's see, chapter 4. Have I done this question? Is it a new question this semester? Getting the quiz up in the background. Probably got time for at least 2 or 3 more questions. Sugar. I know the sugar question. I'll show you what I'm looking at right here. The back-to-back, stem and leaf, compare 2 regions. We've done that one. Is this the... No, it's the crowd crush. Mileage. Baseball teams. Comparing. We hit a bunch that are going to be multiple choice right here. We did these yesterday. 4th graders taking tests. We've done that one. Oh. Horse race. We did the O-Give yesterday. Cholesterol levels. Did we do that one? I don't know if we did that one. Yes, found it. Found it. Here we are. Awesome, everybody. I have to go to lunch. Awesome. See you later, William, right there. Wait, did you do question 1 assignment? We'll come back and do it here, Alyssa. We're doing the questions, or Alyssa, we'll come back and we'll do it. You got it, Alyssa. Don't worry. We should have time. I'll try to do that at least the last 10 minutes or so. We'll come back. We'll check it out. So we will check it out. Got 2 more questions ahead, I think, and then we'll check it out. Thank you, everyone, swinging by asking those questions. Remember, show up early. Ask all the questions. We will have office hours later in the day, too. So if we missed your question, we'll be back. Okay, so people with spinal cord injuries may lose some function, but not all of their muscles. The ability to push oneself up is particularly important for shifting positions when seated and for transferring into and out of wheelchairs. Surgeons compare 2 operations to restore the ability to push up in children. The histogram shows scores rating pushing strength 2 years after surgery, and box plots compare results of the 2 surgical methods. Which of these is a bivariate display of data? Which of these is bivariate? Is the histogram or the side-by-side box plots bivariate? So the histogram or the side-by-side box plots, which of these is bivariate? So what do we mean by bivariate? Bivariate means 2 variables. So you see right here we have the transfer that someone had from the biceps or the deltoid. So I think they're like transferring muscle from a certain area, either from the bicep or from the deltoid. Oh, there you go, the delts. So they're taking from their delts, or they're taking from their bicep, and then they're seeing how much this helps them to push up after an injury. So if this is real data, that's kind of cool because we do see some pretty interesting results, some pretty noteworthy results. And which of these is the bivariate display? So you're looking at someone's strength over here, and this is the number of individuals. It's a rather small data set, but a lot of medical stuff is smaller data sets. And then over here, looking at the strength, so it's the same sort of scale right here. But then we're looking at, because you see it goes from 1 to 5, and this goes from 1 to 5-ish about. It's just that this is starting at 4 and going to 5. So this individual over here, these 2 individuals apparently over here, their data is a little bit interesting. This is what? Which of these is the bivariate display? Who knows? Is the histogram bivariate, or is the side-by-side box plot bivariate? And think bivariate means 2 variables. You might be tricked because you see this right here and you see this right here. But which of these is the box plots are bivariate? And right there, great job, Snea, right there, another 50 points. The box plots are bivariate. And please, if you do not have a picture of this, and a lot of people ask, like, wait, what are the graphics? What goes with what? Please remember all these right here are a great picture to have. Histograms, unless we're doing stacked histograms or something like that, would be univariate. So right there, if we do stacked histograms, like 2 histograms on top of each other, we can compare histograms. If we do side-by-side box plots, we can compare them. But a singular, you can see up there at the top, a singular box plot, a singular histogram would be univariate. And histograms and box plots are for quantitative. If you do it by categories, you would be doing a categorical variable, like breaking them apart. Really good graphical display right here to kind of know each one to use and when, especially if you're 201, because this is a lot of test 1. If you know this and can recreate that, you know a lot of test 1. Describe the shape of the strength distribution. Well, this has 1 peak, making it unimodal. Multimodal would be a bunch of different modal areas, which are concentrations of data. Bimodal would be 2 concentrations. This has 1 concentration. It's very symmetric. You could literally just take this and fold it over on itself right there, meaning it's symmetric. We don't see any outliers here. We're not looking at this. We're only looking at the shape of the histogram, and we see it does not contain outliers. They're only looking at that one. What is the range of the strength scores? Well, you got to be very careful right here, because if you look from on the histogram, you might say it's 1 to 5, but over here you can see it's about 1 to about 4. So I'm a little scared. Round to the nearest integer. See, they're trying to make sure you don't look at the histogram, because the data goes into bins right here. This is any number between 1 and 2, containing 1, up to 2, not including 2. Any number from 2 to 3, not including 3. Any number from 3 to 4, not including 4. Any number from 4 to 5, not including 5, because it goes up to that number. It's in the next bin. And if you notice right here, this number of 4 right here would be about here, thus contained in this bin. We don't actually go up to 5. So it goes from about 1, if you trace over here, to about 4, and that's very clear. So 4 minus 1, 4 minus 1 is the range of the data. Do not be tricked by this right here. What fact about the results of the two procedures is hidden by the histogram? So the histogram does not show a bivariate display of the data. It only shows us the overall results. So if we look at the variation, the difference in averages between the two procedures, when we get to it, this is my question. Oh, there we go. Yep, let's see here. I think that we'll definitely, yeah, great job, Tiffany. You might be next. What method had the better results? Oh, and so then we look over here. It's very hard to see where the median's at on that. So, oh, cool. They're saying it. The median of the biceps procedure, which is not visible in the box plot, is higher than the median of the deltoid procedure, which is approximately. I'm going to zoom in on that. Oh, really? Really? I'm literally going to zoom in. What's the median? Hey, Tingyan, good to see you here. The median for this is where the line in the box plot is at. So that line right there goes to about 2. It's very hard to see that. I think they're going to give you a nice, neat number. Awesome, Tiffany. We should be doing that soon here. Thank you so much. We got this. So the median for the other one is approximately 2. The median has to be somewhere here on the box plot. Usually they like to highlight the line a little bit better. Even though we can't see it, it has to be between like 3 and 4-ish. But that's way higher over here. So there's definitely a higher median on the bicep procedure. Watch out. The bicep procedure is somewhere between 3 and 4. Definitely higher than the deltoid procedure, which has a mean strength of 2. Which was the method with the higher median always better? Yes or no? Simple yes or no on this. The biceps has a higher median. Is it always better? Yes or no? Is the bicep procedure always better than the deltoid procedure? Because we want to increase the strength of these individuals. Is the bicep procedure always better? So, like, yes or no? Is the bicep procedure always better at producing strength? This is the minimum for the bicep procedure. Is it always better than the deltoid procedure? I'm trying to trick you. Is it always better than the deltoid procedure? Yes or no? Is the bicep procedure always better than the deltoid procedure? Trying to trick you. This is a trick people fall into on the test. So this is a really good question to trick you with. Is the bicep procedure always better than the deltoid? The answer is most definitely what? Don't worry if you get it wrong. Is it always better? Is the bicep procedure, this is the minimum of the bicep procedure. This was of the individuals who had the bicep procedure, this was the lowest strength recorded. So we measured their strength, their pushing strength, and this was the lowest pushing strength recorded of individuals who had bicep procedure. So is that always better than the deltoid procedure? Yes or no? Here's the deltoid procedure over here. Is that always better? You can say yes, no, or I'm not sure. What do you think? Don't worry if you get it wrong. Is it always better? Is the bicep procedure... So we have to look, and we need to find the maximum of the deltoid procedure, probably. So we want to look at the bicep and say, this is the lowest we saw for biceps. And then we want to look at the maximum for the deltoid procedure. And I'm trying to trick you, because this is a huge thing people get wrong on the tests. I've had people come to me and say, Brian, I got this question right. And I say, but you forgot about the what? Always remember to look at outliers. This person right here is better than at least some people who got the bicep procedure. So is it always better? The method with the highest median was not always better, because the minimum of that method is less than the maximum of the other method. Let's double check this one. The method with the higher median was not always better because the minimum of that method is less than the maximum of the other method. That's a little hard to read there. I was talking about this minimum is less than the maximum of this. So very important right there. Which procedure produces more consistent results? Aside from the outliers, what do they say here? That's weird. I mean, there's high standard deviations in these though. Let's hear. The two procedures produce equally consistent results because the range of the two data sets are approximately equal. The deltoid procedure has more consistent results. All but two of the data values for that procedure lie in a very small range. But this is such a small data set. 6, 12, 16 people, I think. Sure. I think that's going to be it. Don't fail me now. My Pearson didn't fail me now. That's a good question right there. Good practice. Last question, a little bit iffy on it because you could go between the two. So I don't love those multiple choice on that last one. But it is true. But all but 2 points lie within a very small range. These two would be outliers. And we see a smaller IQR, which is a measure of range. So it's worth noting that there is more consistency, smaller spread of that data noted by the IQR right there. That's got it. Let's do another question. Okay, next question in line is... We have a question from Tiffany. Tiffany's question is next right here. After answering Mohammed's question and Khalid's question, can we work on Chapter 5, Part 1 quiz? Yeah. Tiffany, which one did you want to... Tiffany had the specific one, right? When we get to it, question, companies A, service hotline handles many calls and return companies. The median length... Wait, is this for Chapter 5, Part 1? Is this the one you wanted, Tiffany? Chapter 5, Part 1? So you're saying Chapter 5, Part 1. Chapter 5, Part 1. I got it. Let me go grab it. Thank you, Tiffany and everybody. Everybody waits so patiently. And a lot of questions. It's interesting. This is like the first semester I've done office hours, and I think because I'm teaching so many classes, a lot of people come in and they put their questions, and I love it. So they have their questions ready to go. They're like, I am ready to go. And good way to get your question in. Is this Chapter 5, Part 1, Tiffany? Is it the quiz or is it the homework? It's Chapter 5, Part 1. Is it the homework? I might have changed a question. Is it the homework or the quiz? Because I'm not... Wait, it must be on the quiz. Okay, here we go. It must be on the quiz. 2 seconds. Finding it right now. Whoa. They might just toad someone outside. 2 seconds. Make sure they're not towing me. Not getting towed. It's always worrisome. So it's Company A's customer service hotline. Hey, we found it. Okay, here we go. Let's go check out this question. Let's do it. Chapter 5 quiz right here on company service hotlines for Stat 201. A customer service hotline handles many calls related to orders, refunds, and other issues. The company records indicate that the median length of calls to the hotline is 5.6 minutes with an IQR of 2.6. So this right here is the 50th percentile, and this is the range of the middle 50%. If the company were to describe the duration of all these calls in seconds instead of minutes, what would the median and IQR be? So when we think about what happens to the median and IQR is we know that it took 5.6 minutes. So what is 5.6 minutes to seconds? What do we need to do to take the 5.6 minutes and turn it into seconds? What do we need to do to take the 5.6 minutes? Yep, yours is next, right, Snap? What do we need to do to take the 5.6 minutes and turn it into seconds? What do we need to do to take the 5.6 minutes and turn it into seconds? How can we turn 5.6 minutes into seconds? So how would this change the data if we went from 5.6 minutes to 5.6 minutes to seconds? How could we convert this? which 474, this is a transformation right here. So we're doing a transformation, which won't change the shape. Times it by 60, you are correct. And so that was 336. That's the new median. And then the IQR is going to have the same thing happen to it. The IQR is just going to be times by 60, and there's the IQR. Don't round anything. Now it says, in an effort to speed up calls, the company streamlines the service of push-button menus must navigate, cutting off 24 seconds. Now think about this. They sped everything up. What will the mean and median, what will the median and IQR be? So they sped everything up, which is actually going to change the what of the distribution. Now we're not using a normal curve for this. We're not using the normal curve, but I want you to think about this. Even though we're not using a normal curve, what's going to change about the distribution, if this is like the middle 50% and this is the center, what would change about the distribution? Exactly. That transformation will change the shape of the data. That one's a constant. What will change about the distribution if we speed things up? What will change about the distribution if we speed things up? And then this basically drawing is helping out showing it, because here is the IQR, and the median is where the center of the distribution is. So what would change about the distribution if we speed things up? If we speed things up, what will change about the distribution? And you can see, here's our distribution, and here's us speeding it up. It is taking less time, so what is changing about the distribution? So this is literally like we're up here at maybe 336 seconds, and then we speed it up by 24 seconds. What has changed about the distribution? Like what we'd want to say, I'll draw it even better, is we have a number line down here on the bottom. And so the number line is like we're here at 336, and then we are going to speed this up. Oh no, we're off the screen a little bit. There we go. So now we're going to take this and speed it up right here. So what is changing about the distribution when we change from at 336? That's how long it was taking us, and now we're speeding it up. So what is changing about the distribution? You can see it right here. Hopefully this animation is helping. We were at 336, so now we're speeding up. Like it's faster. What is changing about this now? What has changed about this when we speed it up? We're taking less time right here, kind of on average. Well, we won't have negative. So think about this. So here's the distribution, but what has changed about the values we're taking note of right now? So we're faster, so we have a faster what now? We're faster, so we have a faster what now? What do you see changing as we move this over to the left? What is changing about it? Like what value has changed? Hint, hint, hint right here. What value has changed when we no longer take 336 as a median? What value has changed right here? The what has changed. The median is getting smaller. Exactly. The median is getting smaller. What's happening to the IQR though? So watch the IQR and just look at the IQR. What is happening to the IQR of the distribution? So what's happening to the IQR? And this is the way to understand it. As you see that we're getting faster, the IQR is doing what? It stays the same. That's Tiffany right there. That's for the 100 points. That's exactly it. The median, we see that the distribution now takes less time. The median has decreased by that amount, but the IQR has not changed at all. So that's the answer to the question right here. And when we do this, we're going to see that the median is going to be reduced by this amount of time. So we just need to take and do 336 minus 24, and that's what we were showing right there. And then the IQR is not going to change at all because the IQR is the distribution is still spread out the same, but it no longer, it's quicker. It's been shifted over to the left a little bit. Check our answer, get that 100. Does that make more sense, Tiffany? And that's what I like to do is, we want to understand what's going on right here, that we've sped up the distribution. We haven't changed the measure of spread of it. Changing the measure of spread would be something like this right here, where the distribution is getting tighter. Like we would have to change the variation in the process. The process is quicker, but the variation, which is the spread around the data, hasn't changed at all. It still takes the same variation, but the process is quicker. So we've gone from a 336 median down to here, but the IQR remains the same. We've just decreased the median by this amount. So I hope that helps with that question right there, and hopefully makes it make a little more sense. We should always think of the theory behind it, like what are we doing, what are we seeing, and how does it work? Good stuff right there, Tiffany. Great question. Sneha's question is next right here. Let's check out another 474 question. And thank you for everybody showing up once again. I just can't say that enough. Here we are with some 474 question. Sneha, your question was awesome, Tiffany. Sneha was wondering about, got the next question. I am having, yes, 3A and 3B. 3A and 3B, and you said you had to leave soon. Oh, no. I'll put in the video. 3A and 3B for 474. And then we got just enough time to do the Alyssa's question, I think. Just enough time. Alyssa, great job. Came in here right at the right time. 3A and 3B. Let's talk a little about 3A and 3B. Okay. 3A and 3B for 475. Let's check out some 475, 3A and 3B. So what we have right here, yep. So the t-test, which we're actually going to be doing in 201, very important test right here. And I'll interpret a t-test right here. Let's interpret a t-test. So that's a different one. When you run a t-test, the way a t-test works, it's basic stats right here. We can take any sort of variable we want, and we can test a value. So this is a lot of, basic stats, like the tools we learn in intro stats courses. So Stat 1, you'll be learning this. And we could check somebody's desired weights. Ah, nice job. So we can look at someone's desired weight right here. And if we run t.test by itself, it'll actually give a confidence interval for the values that people want to weigh. So this is, if we went out and talked to all UT students and we asked them, what do they want to weigh? Like, how much do you want to weigh? We think the truth of what students want to weigh is somewhere between 147 to 140, 152. Ah, the interpretations we like is big. That's business analytics is interpreting this. So think about this scenario. We took a sample, right? These are the students we talked to. Like, we talked to all these students right here. 699 students are the students we talked to. These are their responses. And then from their responses, we would guess that the true weight that students want to weigh on average is somewhere between this and this. Does that make sense to say, like, I'm 95% confident that the true weight people want to have is between 147 to 152. And I'm just rounding it to make it a little bit nicer. Because we're taking from the sample what we saw to make a guess about all students. So this is our confidence for all students. Now, we can add in an extra part to this. We can add in mu, and mu is what we're testing to see if it's equal to. What if we want to say, do students want to weigh more than, we want to go here to alternative. Do students want to weigh more than 145? So when we do this right here, look at the interval. And I always hate these one-sided intervals. I prefer to use the two-sided intervals right here, which look like this, which then you could still reject the value because it's outside of it. But look at this. 145 is not in the interval. You're like, well, I think that students, if we had to estimate, I'm 95% confident, want to weigh more than 147. I always hate one-sided intervals, and I don't interpret them. But when we look at this right here, here's the t-test, which is very important. It's a test of a mean. And we're testing the value of 145. This is the tested value. Now, the null hypothesis is what we assume to start, and we assume that students want to weigh 145. But what are we doing, Snea, to that null hypothesis? Because the p-value is low, we're going to say I do what to the null hypothesis right here? My null, which is my starting belief, is say, I think students want to weigh 145. I just believe that in this moment. That's what I'm going to start out believing. But when the p-value is low, when the p-value is high, reject the null. When the p-value is high, just let it fly. And you'll hear this a lot if you're in 201. When the p-value is low, reject the null. That means we're going to reject that the mean is equal to this. That's actually the null hypothesis right here. Not that the alternative is true. We have strong evidence for the alternative. We have good reason to believe the alternative is true. Not that it is true. And don't worry, this is just very finite wording that probably after you get out of college, everyone's going to be like, hey, yeah, the alternative is true. It's like, we have good evidence to believe the alternative. The lower the p-value, the more evidence you have. And think about this, you'd have to be further away. If I wanted to show people I could run faster than a 10-minute mile, imagine if I ran a 9-minute mile. Would that be evidence right there that I can run faster than 10 minutes? If I run, like, on average, if I say I run my miles faster than 10 minutes on average, if you saw me run a 9-minute mile, would that be evidence? Would that be evidence, yes or no? I'll answer the next question. If I run a 9-minute mile, you'd be like, That's some evidence right there that Brian can run his miles in faster than 10 minutes. But what if I ran my mile in 6 minutes? You'd be like, whoa, that's some really good evidence that Brian is faster than a 10-minute mile. What if you saw me run a 4-minute mile, which is absolutely insane? You'd be like, yeah, that's insane evidence. The evidence gets even stronger because it's less likely I'm a 10-minute mile runner if you see me run a 4-minute mile. And this is what p-values are. With what we observed here, we observed a mean of this. it's unlikely that 145 is the truth, because if 145 is the truth, we would only observe a result as or more extreme than this only about 2 out of 100,000 times. Very, very unlikely to observe what we did down here, given the null is true. Does that make sense, Snare, right there? That's probably a big review for you right there. But given the null hypothesis is true, our observed result of 149.46 is very unlikely to occur via random chance. And that's what the p-value is. It's telling us that what we observed was unlikely to occur via random chance. No worries. We can practice this. And whenever you have questions on this stuff, let me know. Your interpretation helps someone strongly. Yep. And so this is it right here. Everything we've been talking about, it's just that we, if someone told me that 145 is the true weight that students want to weigh, I'd say, nah, I've got good evidence to show that people at UT actually want to weigh on average more than 145. And we never say accept the null or things like that, because watch this. Notice here that the p-value is high. Notice here that the p-value is high. In both these instances, you would just not reject the null. I like saying not reject the null. Does that make sense, Naya? Because you wouldn't accept the null hypothesis of 150 and say, that is true. You would just say, that's believable. We might have time, Peyton. We're doing a 30-20 after this. Swing back later today, and we should have time. We'll have to do it later today. Peyton, thank you so much, because we're going to do a 320 after this. So we either reject or not reject. That's my favorite wording. Some statisticians say reject or fail to reject. That's kind of the classical wording. But to me, it makes sense. You either reject or do not reject the null. So in this instance, I can't reject this null. I do not reject it. It seems possible to me. Like this right here tells me that the true mean of 150 is possible given what I observed. Does that make sense? Like this p-value right here tells me what I observed in my sample is possible given 150 is the truth. Down here, this p-value tells me what I observed in my sample result is possible, like very kind of likely, just be a random chance, given 149 is true. But to contrast the other one, what I observed in my sample result right here is not very likely to occur given 145 is the truth. So we see the p-value telling us that this is just a not likely result. Like you'd say, nah, I really don't think we'd get 145. Now, it's possible, but very unlikely. So I'd reject the null, and I say I have good reason to believe that the mean is actually greater than 145. Down here, I would not reject the null. So I would say I don't have reason to believe the alternative. I continue to believe that the mean could be 150. And I'm not saying the mean is 150. I'm just saying that's a possible value. You'll also notice with our interval, we get kind of possible values. Frankly, if you plug any value in the interval like 148 in here, you will get that you won't reject, because values in the interval are possible values, and you won't reject the null. So the interpretation would be the students would want their true average weight to be 150, but the t-test shows that we'd reject the null hypothesis. 145 isn't in the comfortable. Yeah, if someone suggested to you that that students want their weight to be 145, we could reject that value and say we have reason to believe that the weight that students want to be is actually greater than 145. Our data shows good evidence to support an alternative hypothesis. If I'm speaking to someone who doesn't speak any stats, I would just say, I ran a test and it shows that students probably want to weigh more than 145. Like, there's good evidence. They'd say, but wait, you only saw that students want to weigh about 149. I could say, well, we have a very large sample right here, and even though this is only a 4-pound difference, it's enough evidence for us to conclude that they actually want to weigh more than 145. But remember, you can't, if like you were to test the mean of 148, you couldn't reject 148. 148 is close enough to what we observed, so 148 is kind of possible. Does that make sense, how things could be possible given our results? Like with the result we saw, 148 being the truth is possible, but 145 is not really that likely, so we would reject it. Anything is possible, but the likelihood is the p-value. Our data shows good evidence that students, that the true weight that students want to weigh. So I think what you have right there is fine. I'm just kind of turning it even better. Our data shows good evidence to suggest that students want to weigh more than 145, that the truth for what students want to weigh. That, like, because it's not for our sample, it's for like all students. We know our sample wanted to weigh 149, and then we're taking from the sample and making assumptions about all students. Does that make sense, Snare, right there? That the goal of inferential statistics is to take a sample and then to make an inference about the population to say, well, here's what we saw for this sample of students. Now, what do we think is the truth for all students? And we think there's good evidence that students do want to weigh more than 145. If you were to change this to like 140, which is even further away, you'll get a ridiculously small p-value. And now we just have very strong evidence at this point, like undeniable evidence that students would want to weigh more than 140. which 140 is pretty low. Remember, we're talking all students. So, you're going to have guys like me. If you say, Brian, you want to weigh 140? I'd say, that's, no, I can't lose another 30 pounds. That's not happening. I don't want to. So, yeah, good stuff right there. Great question, Snake. And then we'll look at the scaling real quick. This one will be really quick and easy. Don't worry. Like the scaling right here seems really tough until I show you a trick. So watch this. Scale the weight vector in the data frame and report only the first 6 observations. I might just do this one right here. Just trying, because I kind of did a variation on that first one. Can you write an example? We'll swing back here, Snake. We might have to do it later because I'm gonna try to do one more after this. If you want to scale a vector, we have a function inside of R right here, which is scale. So any vector you want to scale, and this is very important for 201, anything you want to scale, and you know what I'm going to do? I'm going to go as numeric because I don't like those attributes. Anything you want to scale, if you want those attributes off of it, you can just do as numeric and it'll make it a numeric vector. Now, these are all whats. Every single one of these is all a what right here. Very important, and we were just kind of talking about this literally seconds ago because it kind of works for this visualization. By scaling something, you turn them all into what's z-scores. So you have a very quick, when someone's like, I have to find the z-score of this, it's like, well, then just, if you have a vector, you could just scale the vector. So you look, we just found 699 z-scores in a matter of seconds. And if you want to take the first 6 observations, I'm not going to code this because I want you to find it. And then, yep. And I think, will it do it right there? You could put it numeric. I'm not, if someone gives the attributes, that's fine. Is this making sense, Snea? We could circle back and do another example. I'm going to do one more question here from 320. Does that make sense, Snare, right there? How's it looking? I could do one more real quick. If we want to test, we have to do a quantitative variable. We can't do gender. We have to do quantitative. If we want to look at the GPA, well, that's the one up there I have, right? If we want to look to see if students have at least one tattoo, this is a test to see do on average students at UT have at least one tattoo. So we want to see if they have more than one tattoo. Let's just less. Is it less? I always forget. It is less. Do we have evidence that students at UT have less than one tattoo on average? Yes or no? Do we have evidence that students at UT have less than one tattoo on average? The z-score is the standardized value. Z-scores are standardized values which tell us how many standard deviations something is above or below the mean. So I can look at this test result pretty quickly and conclude what it means, and I'll then communicate to you what it means. So can you communicate this test result to me? I'll communicate it to you. And we do have evidence. Why do we have evidence? Because we tested to see if students have one tattoo, and we're looking for evidence that students have less than one tattoo. Remember, p-values are always evidence for the alternative. That's a huge thing to know for 201 for any class. P-values are evidence for the alternative. So since the p-value here is low, we're going to reject that null hypothesis up here and say we have evidence for the alternative. So I could say to somebody, we have very convincing evidence right here that on average, UT students have less than one tattoo. I could just, if I don't want to talk stats at all, I might just say, yeah, we ran a test and let me see. We ran a test and looks like there's good reason to believe that students have on average less than one tattoo. Like the general student you would talk to, if you talk to a whole bunch of students, there would be less than one tattoo if you average them together. Let's see the question right here. Z-scores is the standardized value that portrays how many standard deviations away from the mean something is. Yep. How many standard deviations above or below? Above or below, I'd probably say away, because away is fine, but you might say above or below because z-scores can be negative. And if a z-score is negative, something is below the mean. Like this observation right here is 1.5 standard deviations below the mean. This observation right here is 1.35 standard deviations above the mean. So if you think about your test score, you always want to have a positive z-score for your test score. Just depends on context. Like, do you want a positive or negative z-score? Do you want a z-score close to 0? This right here is about at the mean of the distribution, because the mean of the distribution will have a z-score of 0, because it's how many standard deviations you are above or below the mean. Great questions right there. How many standardized values? How many standard deviations? And that's a standardized value. Yep, that's above or below the mean something is. Yep. Great job, Snea. Excellent work and good review of 201. Alyssa had a question. Alyssa's question is... Let's grab Alyssa's question right here. I think it was number 2 or something, right? I wish I could search chat. I think Alyssa's question is number 2. Can you walk through the first question of assignment 2 for loops? I'm just going to start. I want to make sure I'm off to a good start. Yes. First question. I want to type all this out so I remember it. Oh, let's take a look at that first question right there. You got it. Thank you, Alyssa. 100 points for hanging out right here. Let's go jump into that first question, assignment 2 for 320. I think my office hours are, I think my class starts at, yeah, we got time. We got time. We got so much time. So much time. Let's check it out. Let's go grab that assignment for 320. And I'll work a similar problem. Let's go grab that assignment. Thank you, everyone, for hanging out. I know a lot of classes. Swing by, ask that question, and let's go take a look. Assignment getting pulled up right here. And there we go. Repeating name 5 times. I've assigned I to my name. So here's what we want to do. Let's go take a look at the first question for 320 on for loops, assignment 2. So we're going to go to the very first question right here, which is repeating your name. And what we want to do, so we see right here, the question says, a classic question to begin the 474 coding unite, is to write a for loop that prints a paste of your name 5 times with a number as the second argument to show how many times it's pasted to the screen. The coding night is open notes. Yes. So I've asked people this, I've asked them to do this, and then people can't do it, and I get really sad because I tell this was going to be on the exam. So whenever you write a for loop, what do you want to do at first? You don't want to write a for loop. So watch this. Paste Brian. Does that make sense? We have paste Brian right here. Now remember, I beg of you this. Don't write your for loops to start. Don't write your for loops. Snay is right, 100 points right there again. Don't write your for loops to start. Just write your code and get it to do what you want, and then put it in a for loop. I know it's like quicker to just write the for loop. It is if you get it perfect, but even I make mistakes. A lot. So we have here paste Brian. How could I get this to say paste Brian 1? 201, all the things, Celine. Feel free. We had a question about activity, but 201, 320, all the questions, Celine. So good to see you here. 50 points, Celine, showing up right here. Throw a question in the chat. Let me know. If it's a quick one, we might have time. We go till 12:30 your time, but we're in the overtime right now. So how can I get this to say Brian 1? What can I add to this? We did some 201 at the start today, so if you want to, you can actually rewind this video and see where we were doing some 201. Or you can say, hey, Brian, can you do this question next? If you're like, hey, can you solve all the homework? I'm going to be like, we don't have time. Close, Alyssa. 50 points, Alyssa. Very close. You're welcome, Celine, anytime. Just hop in and ask a question. Be like, hey, Brian, can you do this? That's how Alyssa got her question in. She said, hey, Brian, can you do this? And I said, yep, we're going through all the questions. And then we got to Alyssa's. So just, you can always throw in the question. Worst comes to worst, I might say, I've got class in 20 minutes. So this comma right here separates each one of the whats. When we put in a new comma, it separates each one of the whats. When we put in a comma, it separates each one of the whats. And we can't use I yet because I'm going to blank out my environment. Alyssa, great answers right there. Another 20 points. It separates each of the arguments. So right now, what does this do? It pastes Brian 1. Now, you're on the right track by using I. But we don't have I yet. We don't have a singular I. So what could I do right here? Because this kind of helps with the other questions. So don't write everything. I mean, I'm basically working this one, but sometimes people just literally write what I write, and then they're like, I wrote down what you wrote, and I'm like, don't write exactly what I write. Sometimes I work similar stuff. Sometimes I work very close to what you're doing, and this is one of those instances where I'm working very close to what you're doing. How could I create I outside of here? And this is how we can test our for loop to make sure it's working. I want to create I and store 1 into I. I'm basically saying it right there. I want to store 1 into I, and then I want to run this where I is 1. So how can I store 1 into I? How can I store 1 into I? Think about the code right there to store 1 into I. Great job, Snare, right there. You got it. 20 points again in the chat. So we got 1 stored into I. So this still runs the same, but watch this. And let's do this. If you notice, what do we got going on right here? We can now run this code by running I, and I is going to become the what in the for loop. Let's take a look at our for loop now. I is going to become the what in our for loop. We got the skeleton, and I is going to become, Snaz, know what's going on right there. You got it. And I is going to become the what? The placeholder, the variable. Good to see you here, Mary. So let's throw some 20 points. Mary showing up right here. We got the variable right there, which is the placeholder. Great job, Alyssa, the variable, the placeholder. Now we have the skeleton, which is what runs right here. There's the skeleton. And now we want the vector, which is what I goes through. Hint, I kind of did it down here. Can you tell the vector Brian ran through when he ran this right here? I went through the values of what through what. So when Brian ran his code right here by running it, and this is the answers to other questions for 320 and 474, because I'm showing you what I'm showing you right there what your code does. It changes the placeholder to the next element, runs the skeleton. Changes the placeholder to the next element, runs the skeleton. That's what you're seeing right there. So what vector did I go through? When I ran I went through the vector what through what. So when I ran when I was changing I changed it each time through each element of the vector what through what. We're doing this manually right here. You got it, Alyssa. Yep. So we were doing this manually, but here's the thing. When you put it in the for loop, it does it for you. And we want to do a cat paste or something? Because yeah, it doesn't show it. Let me see what it wants you to do exactly, because it's not showing it because it's, yeah, I can do a cat paste. I want to do it exactly the way it says. We're basically doing this one. Create your skeleton. Oh, I know why. Watch this. Does print light take... Ooh. I mean, the way I do it. Let me double check. This is the way I would do it. I don't think it wants you to do it this way, though. I'm going to change it here in a second. I'd do it that way. Let me look at... I would do it that way. Let me see what it wants. Create a vector that will run 5 times. The length of the vector contains blah, 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 blah. Create a vector 1 through 5. Skeleton. Create a placeholder variable. Type autocomplete kicks in. Create your skeleton. Yep. This is the code you want to loop. You want to ensure that you're running. So yeah. Paste. Print say paste. Okay. So you can use print paste. I don't use print paste that much. Probably if we use print paste, we don't... Oops. Really? Print paste works that well? Oops. Oh, it's mad about something. It's mad I didn't close that. Yeah, it's fine. Either which way. I thought a vector was... Correct. So you are correct, Alyssa. That is a vector, and these are 2 ways of doing it we have on the screen right here. A vector can be a vector right here of the elements 1, 2, 3, 4, 5. That's a vector right there. And it's the same thing. You can vectorize something with the concatenate right there, or the... What is that also called? It's basically the glue function, I call it a lot of times too. But come back. Good to see you here, Roger. Good to see you here. So it's running the same thing right here with the for I in vector 1, 2, 3, 4, 5. But this right here, if you look at the 2 lines of code, remember, don't code everything I code. If you look at this right here, this is the same thing as this is the same thing as sequence from 1 to 5 by 1. So all of these right here create a vector, which a vector is just things put in a sequence. So these are all the same code right here, like concatenating a vector of 1, 2, 3, 4, 5, or using the sequence, like the shorthand sequence of 1:5, or using sequence from 1 to 5 by 1 creates that right there. Does that make sense, Alyssa? Yeah, no, great questions, Alyssa. 50 points. Keep asking those questions. There's a lot to learn. There's all these, you know what we say, little bits of coding to learn. And when we say a vector, you might be thinking I have to concatenate it, but you can also get a vector lots of ways. Like you could see right here, be very careful. Do not write everything I write. This right here is a vector right here. So we haven't done the concatenate on this, but it is a vector. So that is a vector right there. Do not be printing these random things to the screen. I sometimes like don't. Don't be writing this. That's not part of your assignment. I've seen assignments where people turn this in and they just go to the video and they write everything I write. And I'm like, no, don't do that. Don't do that. But I think that's got it. Did anyone else have any other questions? I think there was an activity one, but trying to think what other questions are there. If you don't have time, no worries. Oh, wait, here it is. Silly next question. But for visualization number 3, when discussing the mosaic plot, how do we determine if the difference is significant or not? Good question. So let's do, thank you so much, Celine. Almost missed it there, Celine. Let's go look at Celine's question right here. You're welcome, Melissa. Thank you so much. And just keep asking those questions. Snea, how long have you been coding for? Because I love asking people, especially in 474, you have to start somewhere. You start out asking these questions, and you just have to be like, I don't know what's going on. Or like, what does this mean? Or why are you doing this? You have to keep asking questions. I want to ask about the content quiz. I don't know what I did wrong. The last question I did, total neutral divided by total taste. I started coding in R in January. Yep. And he's got to keep asking those questions about what's wrong here. Mary, email me and I'll look over your quiz. So throw me a quick email. It might have been a decimal error. So throw me a quick email, Mary. And I'll take a look at it. And sounds like you might be getting points back. It sounds like it was maybe like a decimal thing. So if it's like a decimal thing, I'll probably just be like, oh, whatever, points back. Let's go look at Canvas content. You're welcome, Mary. Excellent work. Just be like, hey, Brian, I don't think I should have lost points here. I'll be like, okay, let's take a look. All right, let's go to look at a mosaic plot. Let's check this out. Mosaic plots, visualization number 3, how to interpret them. And let's not forget the 4 months I didn't touch R for during the summer. Oops, that's totally fine. And then you just get your brain going again on how to do some R. Visualization number 3, interpretations of mosaic plots. Let's check it out. So this is a mosaic plot right here, and notice your graphic should look something like this. Now I want to show you a quick trick for this. You can take this table down here, if you've created it, and move it over here, just complete and utter. So now when you screenshot this, you don't have to do this, but this is how to make awesome screenshots real quick. There we go, look at that. There we go, look at that. Great. And I'm using the button up here. You have to click it one time, and then you have to drag it over to there. So we just did that, and good. And then I expanded this, because when I take my screenshot, let me go back to the clicker tool up here. It's up top on the Mac. When I take my screenshot, I love for my screenshots to look like this. I do want to note also one last thing. I have deselected everything but count and total percentages, or count and row percentages right here. Associations on jump look so much prettier. I know, and we need to make them look really pretty in R too. Make our data look as nice as possible. That's always one of our goals. Jump's really good because, Jump's a little more expensive, and they have a lot of great ways to display things, and you just want to think, how can I make this look nice and pretty right here? I do like it, yeah, and don't worry if yours doesn't look just like this. Just make sure you take a good screenshot like this right here, and then we want to think about how could we explain to somebody if there's an association right here? Just without even using numbers, what do you notice right here immediately? What do you notice right here immediately? And then I'm going to kind of explain it in words, but what do you notice right here immediately? Yeah, exactly. We need to use some ggplot for that. We could make the tables and make it look, we could beat jump right here. What do you notice immediately? So actually, you are correct. There are more males than females. So that, and that would just be, just in general, we see more males. And then males have broken more bones. So typically speaking, and this doesn't mean if you are a male, you have broken a bone. Of course, I have broken a bone, I'm a male. But we see males on average are breaking bones more often. So going within males, we see 51% or 50.97. If I'm talking to someone, I'm going to say 51. I know, ggplots are so nice. And so we would say here 50.97% of males have broken a bone, opposed to, oh, you can't see that at all. A little better. 37.89% of females have broken a bone. And there are more females. Great job, Lauren, and everybody right here. Great answers. When you compare, this is the comparison part right here, which is very important to see if there's an association. Males would thus be what, and you could actually find this right here. Males would be what to break a bone if you look at this, because I'm kind of connecting the graphic to the numbers. Lauren, excellent work. Males look to be what to break a bone. And you could find this. You could put this in your report right here. You could go, this is a difference of about 13%, and males are more likely to break bones than females. So you could say the difference of about 13.08% suggests that males seem to be more likely than females to break bones. And so you want to think about how you're comparing this, because you're doing people in fraternities or sororities and their political preference. And you might say, people in fraternities or sororities are more likely to be this ideology by this percentage. Is that making sense? I think. Great job, Lauren, Celine, and Snag. Great work. This is good practice. The basics 201. when we look at this right here. And then a final thing for Snare right here, are these differences statistically significant? Are the differences we see here between these two groups statistically significant? So we see these differences. Do we say the percentages for you could do each? There's a lot, but you could say the differences are most noticeable here when we compare people who are in fraternities with this percent to this percent. You could say that they're most noticeable here. Kind of we see that they're more similar here. You don't have to do each. Tell me if you think the graders are mean, but just make sure to be quoting numbers and to make clear you're comparing the groups. So you want to make very clear you're comparing them. And then they are definitely statistically significant. We haven't gotten to this in 201, but the p-value down here tells us that this difference we see right here is unlikely by random chance. And so with this difference being unlikely by random chance, it seems like there is an association between somebody's gender and if they are breaking a bone. Like if you know someone's gender, that would give you information about them breaking a bone. And it just seems logical. It's like not saying if somebody is male, they will break a bone. Just knowing somebody is male means they're more likely to have broken a bone. Not saying they will have, because actually in truth, it's about a 50-50 shot if a male has broken a bone. But males are more likely than females to break a bone. You say, oh, you're female, you haven't broken a bone. What are you talking about? Like over 1/3 of females have broken a bone. So it's very possible that a female has broken a bone, but it's more likely that a male has broken a bone. And this difference we see of about 13% is very unlikely to just be random differences. What if we were to compare, last little thing right here. What if we were to compare people's gender? Where are you at, gender? And we were to compare whether people, honors program is probably going to be females. Sorry. Let's do it. Where's that honors program? I said it's probably going to be... Ooh, Brian was wrong. These differences right here. Now, females are more likely to be in the honors program. If you look at the numbers, females are more likely. This is a little advanced. We're doing a little more advanced right here. The percent of females in honors program is 13%, as opposed to the percent of males is 9.68%. And Snea, this is like an important thing right here. These differences we see right here between males and females in the honors program is likely what? These differences we see here between the males and the females in the honors program are probably just differences that are what? So the differences we see here between the males and the females in the honors program, the higher the number, the more likely these differences are by random chance. Yeah, and so don't worry, Lauren, if that doesn't make sense. That's actually the last chapter is the chi-squared test of independence. And if you notice right here on this one, the number's higher, telling us that this difference is very small. It's a small difference between whether someone is male in the honors programs and females in the honors program. And the p-value is very high right here, telling us that those differences are probably just by random chance. But over here on the other graphic, the p-value is much wider because the difference is much larger, telling us that this difference is unlikely by random chance. Is that, I think Snea might get it, but don't worry. She's in the senior level classes. 201, does anyone understand right here when I say that this difference I observe right here is very unlikely by random chance? Lauren, excellent work, 100 points. Advanced topic. You're going to get ready for the future with this, for the future of the class at least. But yes, Lean, awesome work. This difference we see here is unlikely by random chance, given that there's no association. This difference right here is, it seems possible. So even though more females are in the honors program right here, the differences are kind of small, and it could just be that our sample had more females than males in the honors program. Like, is there really some sort of gender difference between being in the honors program? The data, although more females are in the honors program, we can't conclude that there is an association between gender and being in the honors program. The differences are small enough that they could just be bi. That's got it, everybody. It's the end of office hours. I can't play this. I would love to play this song out, but I got a copyright strike one time, and I don't want the video to get ads on it. If you ever see ads, it's probably because we got copyright striked, or it's a I don't know. I put ads on some videos, not on these videos. But that's got it. 320 saved me from the lack of interpretations I dealt with in stats. Yes, you need these interpretations because why do you need, like, if someone's like, why are you learning stats? You're like, to interpret the data and to give it understanding so we can use it. If you're in biology, chemistry, kinesiology, all these different fields right here that look at data, you're not just running equations. You're saying like, yeah, we ran the result and it looks like there's nothing going on right here. Like gender and whether someone's in the honors program, no real association. If there is differences, it's probably just because just a few more were in the group and it's like, whatever. I never saw them until 320. Yep. And it's good categorical display of data. I'm throwing another 100 points. You know what? I'm throwing 200 points. Thank you so much for all this interaction here at the end. See, the thing is like this is if you want office hours to keep going, just keep having fun, keep interacting. It really is a lot of fun for me, especially when people are like, oh, like answering the questions and all that good stuff. With that, it's the end of class right here. It's the end of time. It's the end of time. What's the next tier? You'll have to find out. You might be getting close to that next tier. Keep getting those points. A bunch of secret tiers in the background. There's tiers up to 50,000 points. I'll tell you at the end of class what the tiers are. I think, Snay, you're getting really close to next tier. 72 hours. That's so awesome. Keep swinging by. Keep checking out. Keep asking those questions. Remember, review the basics, even if you're in the upper level classes. Snay, one question. This thing that 201 is doing, is this important in 320? And do you think it could play some role in 474? You know, maybe we'll start seeing stuff like this in 474. Do you think the basics is very important? For like, if you know this in 201, would that help you in upper level classes? I'm answering the question. The answer is most definitely yes. The basics are going to be a huge help. The better you learn the basics throughout 201, you go into 320, you're like, this is easy. I learned this in 201. So we're literally doing this in 475 right now. We are literally doing the basics. We're about a little under a month into 475, and we're making sure we know the basics because they're so important. With that, learn the basics. I'm going to guess yes. Learn another 100 points. I don't care. It's not Wacky Wednesdays. It's Throwback Thursdays here on Stat 201. I'll see everybody later. We're going to start some 320 here soon. 320, be seeing you soon. Bye for now, everyone. Bye. Throwback Thursday.